So in this question, we're going to try to figure out whether B is a linear combination of A1, A2, A3, A3. If B it is a linear combination, then B has to be written like this. So we say there exists C1, C2, C3 such that B can be written as C1, A1, C2, A2, C3, A3. But this is really a matrix equation, right? This is really a matrix equation where we say A1, A2, A3 are a column of the matrix and B is the right-hand side. So we can form an augmented form here, right? Augmented matrix here. So this is really a matrix equation. So we can call this A times X equals B, where A is really just this. So I'm going to write down the A now. A is just a matrix. 1, -2, 0, 0, 1, 2, 5, -6, 8. So A is this. This is the matrix A, which is the column A1, A2, A3 are the column, and B is the right-hand side. So I form an augmented matrix. So I put that as an extra column, tag it into the matrix. Now I'm going to reduce this. So if this augmented form has a gives us a solution, that means C1, C2, C3 exist, right? So and therefore B can be a linear combination. So that's what I'm after right now. Okay, so now let's try to row reduce that. So we can choose this as our pivot position. So this is our pivot. And then we can introduce this row operations to make everything below 1, 0. So 2 row 1 plus row 2, put it in row 2. And then this is already 0, so we don't need to do anything here. Okay, let's just work with this operations only for right now. So 1, 0, 5, and then we have 2 here. This is 0. This will stay 1. And then multiply this by 2, 10. 10 minus 6 is 4. Multiply this by 2, 4. 4 minus 1 is 3. Then we have the other number. So this is like 0, 2, 8, 6 right here. Okay, now I choose my next pivot. That's going to be in the second row, first non-zero. So that's this guy, right? This is our pivot, next pivot. And I'm going to make everything below and above 0. Above is 0 already, and I have to just make that below 0. So introduce my row operation. It's -2 R2 plus R3, put it in R3. And then we'll get this. So we'll get, okay, 1, 0, 5, 2 here, 0, 1, 4, 3 here. This didn't change. And now this becomes 0 here. And we multiply this one by -2 added 8. So this is also 0. And we multiply this by -2 added here. This is also 0. This right here tells us, right? This right here tells us that there is actually a solution. Why is that? Because this is a pivot position. This is a pivot position. And we're not going to have any pivot position here. So therefore, this is going to be a free variable. So if our system contains a free variable, then it's going to have infinitely many solutions. So these two are basic variables, right? Because they contain pivot. So one free variable means we definitely have a solution. In fact, we have infinitely many solutions. So therefore, this guarantees that C1, C2, C3 exist, and therefore B will be a linear combination of those vectors A1, A2, A3. And in fact, we can also say now B will be in the span of A1, A2, A3, right? That's basically it. So here answer is yes.